This is the brief on boundary conditions and the circular membrane wave equation. All right, so we're looking at the physics that defines how something like a drumhead vibrates. And the main thing to get here is how the physical constraint, right at the edge, completely determines the final solution. It basically rewrites the physics. First, let's talk about the classic drum. That operates under what's called the Dirichlet condition. So what does that mean? Well, it just means the edge is held totally rigid by a frame. The movement right at the boundary is always zero. And this constraint, it gives you that classic drum shape with the most movement in the center. But crucially, it results in a lower, deeper, fundamental frequency. Second, let's flip that with the Neumann condition. Now, this is different. It doesn't fix the edge in place. Instead, it just requires the boundary to stay perfectly flat as it vibrates. It seems like a small change, but it creates a totally distinct vibrational mode. You still get that peak in the middle, but the result is a significantly higher fundamental frequency. So finally, what's the big takeaway? It's that the physical constraints are just everything. The membrane itself doesn't change, but just by switching how you hold the edge, from fixed to just flat, you completely alter the shape of the vibration and its frequency. So that simple rule at the boundary, whether the edge is locked down or just kept flat, ends up dictating the entire vibrational behavior of the whole system.